Okay, so this is the start of chapter 14. And remember that in chapter 13, we talked about sampling distributions for proportions. So in chapter 13, our sampling distribution looked like a normal model where the population proportion is representing the mean and the standard deviation is P times Q all divided by N. And if we have this sampling distribution, we can use normal CDF or inverse norm after making sure that we find our mean and the correct standard deviation. So we want to apply a similar concept to means. So a sampling distribution, let's remember a sampling distribution, for a mean, it's when we continue to draw random samples from the population of the same size, and we use a model to estimate what will happen over time when we continue to do this. So models what the distribution of data would look like if repeatedly sampling from the population, the same population. What we find is essentially that this distribution is modeled as well by the normal model. So if the population data is modeled by a normal model where my mean is mu and my standard deviation is sigma. Let's say this is the population data and the model that we use. If that's the case for our population, then the sampling distribution for samples of size n, little n, looks like, and that would be another normal model where I have the same mean, but I take my standard deviation and divide by the square root of my sample size. So I have the population mean as the mean for my sampling distribution, but what I do is I take the population standard deviation and divide by the square root of whatever sample size we're hoping to achieve. And then we can use this normal model to answer any questions about samples of size n. Right, so if we get a specific sample size given, let's just say like 25, for example, then we would create a sampling distribution for that particular sample size, and that would only be true for that sample size. So our sampling distribution would change if the sample size were to increase or to decrease. And now there's one other thing that we want to talk about before we go and see a couple examples, and it is the central limit theorem, okay? So I kind of already addressed it in the first comment above, but it is basically a two-part theorem, okay? So if a sample is drawn from a population that follows the normal model, that would be the mu and sigma we just saw above, then any sample of size n follows the model we just discussed, where we take our original standard deviation from the population and divide by the square root of that sample size. So this is the case where our population data is, we're actually told that it follows a normal model. And the second scenario would be if we do not know that our population data follows a normal model, which would be told. This would be like if our data is skewed or if our data is bimodal, okay? So remember, normal, let's just give my dog is chewing on a damn toy over here. Normal means unimodal and symmetric, right? So what we are looking for, if it's not normal, right, is that it's not unimodal or symmetric. So if the data from the population is not normal, we can still use the normal model where we repeat the same population mean and take the take the standard deviation and divide by the square root of the sample size if we are given a sample size greater than or equal to 30. Okay? So we can assume the normal model applies if our sample size is large enough. Okay? So remember this particular piece of information because we're always looking for our sample size to be larger than 30 or for the problem to tell me the data follows a normal model, so I can just assume I can apply the two functions we use in our calculator when we have a normal model. So remember that we would then go to our calculator and our only options for this particular section of this chapter would be that we could find out some information using normal CDF or inverse norm with respect to the model we create for the sampling distribution. This would be very similar to how we used normal CDF back in chapter 13 when we had a sampling distribution for proportions. So remember, this up here in that first line is for proportions. Okay, and this one right here is for means. So we have two different sampling distributions, just to clarify, okay? We're going to follow this video up with a few notes, or a few examples, excuse me.